So what did you get for number 1? Let's make it really easy to start with. Oh, you got L. Excellent. How did you get L for number 1? Okay, so when you're multiplying like bases, what do you do with the exponents? You add them, right? Okay, what did you get for number 2? Aren't we still multiplying like bases? So we should, x to the 12th, we should add the exponents, right? What letter is that, by the way? H. Okay, what did you get for 3? So we multiplied the numbers, right? So 20, and we're multiplying like bases again, so what do we do with the exponents? Add them. So 20x to the 16th. What letter is that? C. All right. What about 4? What happens when you're dividing like bases? What do you do with the exponents? Subtract. So we should have gotten x to the 13th. And that is m. Okay, what about 5? Oh, we're multiplying like bases. What do you do with the exponents? We add, right? So negative 3. That's not over here anywhere. Are we allowed to have negative exponents? What happens when we have a negative exponent? Where does it really want to be? On the bottom. But if it's already on the bottom, where does it want to be? On the top, right? So I'm going to start that conversation over again, and we're going to use our some better vocabulary, right? So if we have a negative exponent, where does it really want to be? In the denominator. If it's already in the denominator and has a negative exponent, where does it want to be? In the numerator. Excellent. So this is really 1 over x to the 3rd, right? Oh, D. Okay. What about 6? I have some sort of stuff that I'm squaring. Please keep in mind that we have to square everything in here, don't we? Okay. So if I square the 7, I get 49, and if I square the 8, oh, so you're going to multiply those two? Oh, good. What letter is that? S. Okay. What about 7? Right, so I'm squaring everything inside here, so I get 3 times. That's 16x to the 16th, right? And then I have 3 times that whole thing, so I have 48x to the 16th. Which is A, thank you. Okay, what about 8? What do I do with the 14 and the 2? Do I subtract them? But you said a minute ago for dividing like bases, we subtract. X and X aren't like? What do I subtract, though? The exponents, not the numbers. The numbers it's asking me to divide, right? That's what this whole line thing is right here. So 7x to the 16th. Very good. What is that? B. Oh, V. Are you guys making up stuff? It's E. Okay. So what about 9? We subtract, but if we say 3 minus 4, that's negative 1. Could we start here and say 4 minus 3? And that's just 1 over x, because that's where I started, so that's where I leave the answer. So 1 over x, which is W. Okay? What about 10? Ooh, 10's getting really messy, isn't it? Yeah, we don't care about that. Add these two, right? What's negative 5 and 12? 7. And what do I do with the 7 and the 3? Multiply. So I have x to the 21st over x squared. And what do I do with these now? So x to the 19th, which is letter N. What about 11? Okay, so 5 and 8. What do I do with those? Add. Very good. 5 plus 8 is 13. And then what do I do with the 13 and the 2? Multiply them, which is, so x to the 26th over, what do I do with this 2 and this 3? Multiply, so x to the 6th, so what does that end up being? X to the 20th. What's that? Oh. What about 12? Am I multiplying like bases? Oh, I'm adding. So this is really like 1 x to the 10th plus 1 x to the 10th plus 1 x to the 10th, and I get 3x to the 10th, which is t. So did you fill in the letters at the bottom? Calm down. Remember what he said? Quick, I don't remember how to change the fraction 1/5 into a decimal. You got to help me. Hurry! Because it's an emergency, right? So the teacher says to the student, calm down. You are 2 2/10. Little math humor. It's all good. It's not really funny, and that's okay. Yeah. Yeah. It's okay. Okay, you get it. You get it now, right? Okay, so here's a road we're starting to travel on today. Okay? Consider the function 9, y equals 9 to the x power. Complete the table. Well, I don't want to take the time to use my calculator. I just need to be able to do this. Okay? 9 to the negative 2 power. Remember we just said that if it's a negative exponent, we move it to the denominator. So we have 1 over 9 squared. What is 9 squared? How about 81? Is that okay? This would be 9 to the negative 1 power. If we move that to the denominator, that's just 1 over 9. What's 9 to the 0 power? 1. What's 9 to the first power? 9. What's 9 to the second power? 81. What's 9 to the third power? A very big number. Wow. How about 729? What patterns do you see emerge on the y side of the table? From here to here to here. It's getting bigger, but it's getting bigger by 9, right? It's getting bigger by a factor of 9. To get from here to here, do I have to multiply by 9? Multiply by 9. So we're multiplying by 9 as we move down the table. Sorry, I accidentally was writing in pencil. I know it's hard to see. I'll write in pen. Now we kind of need to use a calculator because it says use a calculator, okay, to expand the table between 1 and 3. Okay? So after you have your calculator on, we want to go home. I mean, not actual home, although we probably do want to go to actual home, but we want to go to home on our calculator. Start a new document that is a graph, right? And what do we want in the function line? 9 raised to the x power, right? Does everybody know how to make it raised to the x power? The little housetop carrot thing right there. I don't know what you call it. Don't make fun of me calling it carrot. Rude. Why are you a carrot? You don't know. So let's go to the table. So Control T. How are we going to change our table to make it look like this one though? So menu and table and edit table, right? That's what you said, isn't it? So we want to start our table somewhere 0.510, somewhere just around here, right? And we want it to, how do we want it to count? 0.5. Okay. Something I figured out about this calculator is if I started at 0.5, that's the one that's right here that you can't see. So I always start it a little bit before I want to be able to see the things, because otherwise I won't be able to see that one. I'll have to arrow back. Not that that's much work, but I mean, sometimes my finger gets a workout when I'm working with the calculator a lot. So when x is 1, y is 9. When x is 1.5, y is 27. When x is 2, y is 81. When x is 3, y is, or sorry, 2.5. 243, and when x is 3, y is 729. When this table is in this form, what pattern emerges? Is it multiplied by 3 every time? Times 3? 27 times 3 is 81. 81 times 3 is 243. So we're multiplying by 3 as we move down the table. Does that seem weird to you? Okay. So before being able to compute 9 to the 1/2 or 9 to the 3.5, I don't know why I said 1/2, 1.5. Let's consider 9 to the 1/2 power. Just 9 to the 1/2. Okay? What? No, just 1/2. 1/2. What is 9 to the 1/2? What does an exponent of 1/2 mean? Complete this equation. 9 to the 1/2 times 9 to the 1/2 equals what? When we're multiplying like bases, what do we do with the exponents? What's a half plus a half? So 9 to the 1. Does that make sense? Okay. So let's make 9 to the 1/2 equal x. So if I say x times x, because both of those were 9.5, or 9 to the 1/2, right? So I'm replacing that with x, equals 9. What's another way to write this? X squared equals 9. How do we solve for x? So I square root and square root. What's the square root of x squared? And here would be the square root of 9, but don't we know the square root of 9? It's 3. So 9 to the 1/2, because remember we replaced x with, or 9 to the 1/2 with an x, right? This is what 9 to the 1/2 means. 9 to the 1/2 means 3. Okay, so let's use a calculator. 4 to the 1/2 power. 4 raised to the 1/2 power. What is 4 to the 1/2 power? 2. What is 25 raised to the 1/2 power? 5. What's 256 raised to the 0.5 power? That's different, isn't it? Well, it's different the way I put it in, because I put it in wrong. Huh, I got 16 as well. What's 42.25 raised to the 0.5 power? 6.5? I got 6.5. Did I put something in wrong? You got the same thing? So 6.5? What's 3 raised to the 1/2 power? So same as me, right? 1.73205, is that what you said? So what's 80 to the 1/2 power? Oh, see, I was being tricky. I put in 0.5. Is that okay? That's not what the problem says. Oh, it's the same thing though, right? So 8.94427. 0.94427. Do it. You think it's 10? Did you do it with a calculator or without? Do it with. Just to check. 100 raised to the 1/2 power. Oh my gosh, we are so smart. What are we, you're welcome. What are we doing when we're raising something to the 1/2 power? What common mathematical process yields the same results as an exponent of 1/2? Square root. Okay. We good so far? Okay. Other side. Consider the function y equals 8 to the x. Complete the table. What's 8 to the negative 2 power? 1 over 64, right? Because it's not 8 times 2, it's 8 squared, right? What about 8 to the negative 1 power? 1 over 8. What about 8 to the 0 power? 1. 8 to the 1 power is 8. 8 to the second power is 64. What's 8 to the third power? 512. So what patterns do you see on the y side of the table? That's multiplied by 8. 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 I don't want to just put it once, because if I just put it once, is that truly a pattern? I have to check each time, right? It's only 5 things that you have to check, 6 different table entries, correct? So we are multiplying by 8 as we move down the table. Now, why am I being so specific about we're moving down the table? Is there another pattern in this table? Oh, if we divide by 8, if we go up the table, right? So that's why I'm trying to be really clear about which direction we're talking about. Sorry about that. Okay? Now, same kind of deal on this side as the other side. We're going to use a calculator to expand the table between 1 and 3. Okay? So I need to go make a new document that's a calculator. No, I don't want to keep the old one. I mean, not a calculator, a graph, pardon me. And what goes in f of 1? 8 raised to the x, 8 caret x. Emilio's making fun of me. Great. I go to my table, Control T, and I need to go change my table settings, don't I? So table, edit table settings. Where do I want it to start? 0 is fine. How do we want it to count? Well, if I made this a fraction of something thirds, it would be what? 3/3, right? 3 over 3 is 1. So 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. So how are we counting? By 1 divided by 3. 1 by thirds. Okay? So tab down until we get to OK. And then we see our table. So I already know that 1 is 8, right? 1 1/3 is 16. 1 2/3 or 5/3 is 32. Now this seems really weird, once again, that these are nice whole numbers when I'm counting by thirds. Doesn't that seem weird to you as well? So this one is 60. Oh, no, we already have 64. Sorry. 128, 256, and 512, right? Is there a pattern that you see? How? As we move down the table, we are multiplying by 2. Very good. So multiplying by 2 as we move down the table. Okay? So before being able to compute 8 to the 4/3 or 8 to the 10/3, let's consider 8 to the 1/3. What is 8 to the 1/3? What does an exponent of 1/3 mean? So does this look similar to something we did on the other side? Good, it should. Okay. If we're multiplying like bases, what do we do with the exponents? Add. So what's 1/3 and 1/3 and 1/3? So that would be 8 to the 1, right? Okay. So this time we're going to let x equal 8 and 8 to the 1/3. So this is 8 to the 1/3, so it's an x. This is 8 to the 1/3, so it's an x. And this is 8 to the 1/3, so it's an x. And what does it equal? 8. How do I rewrite this side of the equation? X to the third? So x to the third equals 8. How do I solve for x? Oh, a cube root. What do you mean by that? Like a square root would be what times what equals that number, right? A cube root, exactly. What times what equals that number. So it looks like this. Wait, I thought that was a square root. I'm not done. I'm not done. Aw, a little baby 3 on the front. Cube root of 8. The cube root of 8 is what? What times what equals 8? 2. That is what 8 to the 1/3 means. So let's use a calculator to evaluate these. Okay? What is 64 raised to the 1/3 power? 4. What is 216 raised to the 1/3 power? 6. And what is 500 raised to the 1/3 power? Oh, that's messy, isn't it? 7.93701. Without a calculator, tell me what 125 to the 1/3 power is. 5. How do you know that? What common mathematical process yields the same result as an exponent of 1/3? Okay. So if something's being raised to the 1/2 power, that's the same as square root. If something's being raised to the 1/3 power, that's the cube root. Let me show you one more thing before we go on. Okay. On this side of the paper, when we took the cube root, we had a little baby 3 right there, right? Okay. How come if this is taking the square root, how come we don't have a little baby 2? So you're saying we don't need it? Look at this variable right there. What is the exponent on this variable? How do you know that? Oh, so I don't need it? But there's one there, right? What's the coefficient in front of this x? A 1. How do you know? Oh, but you don't need it, but it can go there, right? So could I put a little baby 2 right there? Yes, it's understood that it's there because that's the one that we most commonly use. Okay? It doesn't have to be there. It can, but it's understood because we use it the most often. Okay? Any questions? What kind of sign off do you want me to do, Emilio? Peace and out? Kingston out. Kingston out.